I am back with another question, this time making you a lemonade wala. So we are solving 860 lemonade change lead code. So this time you are at a lemonade stand and each lemonade you are selling at 5 rupees. Now you have got customers which have 5 rupees, $5, $10 and $20 denominations. You are going to provide them change. If you are able to provide them the correct change, then you have to return true, otherwise false. And one thing to note is that you do not have any change at first. You have just set up the business in the morning.
Now, on carefully understanding the question, we can realize that every time we have to deal with one customer. So, we don't have to worry about the future customers and their changes. We have to just satisfy the present customer. So, we are only concerned about the present situation and not worried about the future. This is indicative of the greedy approach, that is, we are concerned about the present optimal solution that will eventually lead to the future global optimal solution. Let me explain you the algorithm to better understand. So, as mentioned in the question, we will be starting with initially no change. So, we do not have any 5 rupees notes or 10 rupees notes. Then, and we will encounter each customer one by one. If the customer pays a 5 rupees note, then we do not have to keep any change for it. We just have to keep the 5 rupees note because the amount required for a lemonade is rupees 5, so no need of any change given to the customer. Then if possibility the customer is paying you rupees 10, then we must give him a 5 back. So firstly you have to check if we have a 5 rupees note or not. If we do not have, then we cannot pay the return, so we will return false. If the customer pays a 20, then we have to return a 15. So in 15 there can be two cases, like you can have a 10 and a 5 rupees note, or a 3 5 rupees note, like you have 3 5 rupees note. So checking whether which is present, we will return it accordingly. If neither of them is present, then we have to return false because we are unable to give him the change. Now if we are able to satisfy all the customers, then we can return true. Otherwise, we must have returned false if we failed to return any one of them, not the right change. Now, let's by this algorithm only we can figure out the time complexity. So, for keeping the current number of 5 rupees notes and 10 rupees notes, we require two variables. Then we are traversing the whole loop for the customers, so that will hold a time complexity of O of n, because we are traversing the whole size n. And for the space complexity, we are using just two extra variables, so that would be O of 1 only. I hope I made myself clear. Now let's understand the algorithm with the help of an example. So the first step says to initialize two variables 5 and 10 for the count of 5 and 10s. So let's initialize 5, which holds the value number of 5s at present, and a 10s that holds the number of 10s at present. Let's number it 0 1 2 3 and a 4. Okay, Let's start. At I is equal to 0, customer came with a bill of 5. So, do we have to give any change to him? No, we do not, because the price of the lemonade is 5. So, let's just increase the counter of 5 to 1. Then at I is equal to 1, the customer came with a 5 again. So now the counter for 5 increases to 2. Then I is equal to 2. Again customer came with a 5. Again we have another 5, so its count is 3 now. Then customer 3 came with a 10. So 10. Firstly, we'll check whether we can give the 5 as change or not. For that, do we have any number of 5s present? Yes, we have 3 5s. So that is sufficient for giving 1 5 at change. So let's give the change to the customer. So the count decreases to 2 and we got a 1 10. So let's increase its counter to 1. Then the customer 4 came with a 20. With a 20, so we have to return a change of 15. So 15, there were two possibilities, like we can give him a 10 and a 5 or 5 3 times. Let's check first for 1 10 and 1 5. Do we have both of them? Yes, we have both of them. Let's give both of it 1 1, so its count becomes 0 and its count becomes 1. Now there are no more customers, so we actually ended up giving all the changes to the customers correctly, and thus we will return true, which was the output.
Come on, let's quickly code this. Let's start by initializing the bills size. Bills dot size. Then we are going to traverse over it. And as discussed in the dry run, we need to keep a track of how many 5s and 10s do we have, and a 10s variable for it. If we encounter a 5, bills of I will be equal to 5, then we do not need to return any change. We just need to increment the 5 counter. Else if we encounter a 10, bills of I equal to 10, then we have to give a 5 change. But let's check if 5 is present or not. If 5 is present, then we need to give a 5 change, and we have attained a 10. Elsewhere, we do not have a way to return a 5 change, so we must return a false. Else, there is no other denomination than 20, so no need of writing the condition. If there is a 20, we need to return a 15. So 15 is having two ways. Either we can give as 5 plus 10, or we can give 5 3 times. So like, let's write both of them. If there is a 5 and there's a 10, we can give them 5 minus minus and a 10 minus minus. Else if we have a 3 5 5s, 5 minus 3 is greater than equal to 0, that means we have 3 5s, then we can give all of them Elsewhere, we do not have any other way to get return. Change the false. Now, if we didn't return any false in the loop, that means we were able to traverse on the loop till the size of it. That means we were able to satisfy each customer with its return. So we were able to achieve our target. So return true. Let's check if this works. Let's submit it. Yes, thank you so much.